present, right? It's just disrespectful. And try to avoid doing distracting movements when you're doing a presentation in front of the class, right? You would be so surprised as to how many people will do weird things and not even notice, right? Just something like this, just hanging out, right? Like, don't do that. Don't do that. What? Okay, so visualizing stuff. So why are visualizations so important, right? And why are they so big now? Well, for one thing, we couldn't do them before, right? Making a graph, like imagine trying to make a 3D graph like 20 years ago. It takes your computer like a minute to create the thing, right? Like, so imagine like just like even 5 years ago how long it would take. So like we're just now able to do really awesome visualizations because visualizations are very hard, right? It's a lot of math behind it, right? You're mapping different variables on different systems, right? With different ranges to different variables. You're mapping things to circles and squares. Like, there's just a lot of crazy stuff going on. So, what is this visualization doing, right? Is it showing the relationship between variables? Not really, right? Predicting outcome? You think it's doing that? I would say yes, but more so the third thing, right? Complicated stuff in general. So graphics are awesome at showing super complicated stuff, right? Bayesian networks, geometric curl. That's super complicated, but the graphic, right? The fact that you can see these nodes and edges connecting a complicated network. If you've ever studied a convolutional neural net, recurrent neural net, those things are super complicated, but you can see what's going on, right? It's a complicated system that's like so modularized, right? You can break it apart, right? And then look at each individual part and just like look at it graphically and figure out what's going on. Have some good labels, right? So what is this doing? Well, this is doing object tracking, okay? And so you can see densities and changing dynamically, right? This is time axis, so you can see you can see something very, very complicated going on, but you sort of know what's going on just by looking at it, right? If I would have shown you the algorithm instead, or the paper that it came from, very, very complicated. But you can just like see this and say, oh, the highest density right here, maybe the mode of the distribution is where the dude's at. That's exactly what it is. All right. Who is this, or what is this?
Basketball court.
Basketball court. What's the heat?
Where they shoot from.
Right. Absolutely. So maybe it's fraction of completed shots made from a specific area, right? So we'd expect him to be pretty good at making 3-pointers right here, and then just destroying it right there, right? So that's, anyone know who that is?
Curry.
Curry. Yeah. How might a team take advantage of this information? How might the opposing team take advantage of the fact that when he is right here, he's gonna get it in?
Maybe double team there.
Yeah.
Change of defense.
Exactly. Now, what about for being on Golden State? How would you use that info?
Set screens. Maybe set up a play.
So, the point is that there's a lot of stuff you can do with that information, right? A lot of stuff. Historical example, Florence Nightingale. Does anyone know who Florence Nightingale is? Her name. This is okay. Okay. So Florence Nightingale is also known as the mother of modern nursing. She was a nurse during the Crimean War, which is the war between Russia against I feel like France, Britain, a couple other people, and so what she did was she looked at data from the soldiers and said, all right, what are these soldiers dying from, right? She had this idea that sanitation was just destroying the army, okay? So she looked at that data and she said, wow, look at that blue, right? What do you think that blue is? Something important, right? Something that really outdoes this red or black, right? You can't see any of those axes, right? Well, you can see this thing right here, barely, but you didn't even need to, right? You just knew, wow, all I need to know is what that blue is, and that was the big thing, that was the big killer. So the blue is preventable or mitigable zymotic diseases. My dad, when he watches this, he's going to be butchering me since I couldn't pronounce Yeah, so preventable diseases. So this isn't deaths due to like getting shot and killed in action, right? This is them having an infection and dying, stuff that's preventable, right? So bam, like look how easy it is to read that, right? And this was 1858 at the time. They had barely discovered the pie chart, like 10 years earlier, right? And then you got the coxcomb just coming out of nowhere, spiral histogram, bam, super easy to interpret. And she's able to convince Queen Victoria and the rest of Parliament to make major changes to sanitation. They said that the mortality dropped from like 58% to 2% in like just like 1 or 2 years after she made those changes. That's huge, right? So you can see why she's called the mother of modern nursing, and why it was so important to convince Parliament, who doesn't know anything about statistics, right? You need to quickly show them that they need to spend money to completely eliminate this problem, right? Pretty easy to show. Napoleon's March, also pretty epic graphic. This graphic has actually been called the most honestly, I was about to say the dankest graphic of all time. This graphic has been called the dankest graphic of all time by famous people who have seen it. As we can see, the army here starts. Think of the width here as the size of the army, right? And we're just tracking this over time, over time, over time. Bam. Continuing time, continuing time. What are we left with here? Like, wow, wow. Okay. This graph actually shows 6 types of data. It's like 6. It shows temperature, it shows time, it shows like major events. Those are what the labeling is. Crossing a river, look at that river. Crossing a river, crossing another river. Look at that, look at this main point. Crossing this river, and then you're halved. Right? Crossing a frozen lake, probably. Okay. Leonardo da Vinci, what does this graphic tell us? Proportions. Exactly. Proportions of the human body, right? Do you think he had data? What was Leonardo da Vinci? Did he have, what data did he have to create this?
Measurements?
Some creepy data. Da Vinci had some creepy data, that's what he had. Okay. Yeah. All right. 20 questions. How many of you guys have had that little orb, 20 questions, that game, right? And you like guess something, and you're like, all right, I'm thinking of a 3x3 identity matrix. It's never gonna get it. It's never gonna get it. And you're thinking of it, and then it asks you these questions, and then finally at the end, it's like, were you thinking of a 3x3 identity matrix? And you're like, no way. How to do that? Mom, were you telling him? You know, it's epic. It's like AI craziness. And like I got this point when I was a kid, I didn't appreciate it at the time, but it's just a decision tree, right? Now we have like random forest, like right, we could absolutely make this thing super complicated and accurate now. But how was it trained? Was it trained by him just like typing in, all right, let's go if this then this down 20 layers, right? No, he didn't do it. He didn't have 20 switch statements, right, or a billion switch statements. He started programming himself, would think of a new thing and add it in and give it to his friends. Sent the software to all of his friends who would add in stuff, right? It's this distributed computing, right? But distributed among people, right? That built this epic game. Right? It was a website or like an applet, and then it was made into like a digital. Infant mortality by county. So look at this visualization, right? This is like using ggmap. Right, we have, what do the colors say? The colors, so the darker the color indicates a higher infant mortality rate, right? And we have, each of these points are centered at the center of the country, I think, and yeah, right, it's alarming. You see Afghanistan, which is, it sort of confirms intuition, but it's pretty alarming. And looking at Africa too, right? Chernoff faces. How do you portray higher dimensional data? You have something in 3 dimensions, perfect. Euclidean graph, x, y, z. I can visualize that. 4D, ooh. 5D, oh, 6. Okay, how about 4D? Right, well, what can we do? How can we represent a 4-dimensional object in 3 space? So we want to do a 3D graphic. Color, bingo. Color will represent that for you. Okay. How about Chernoff faces? So what is a Chernoff face? Well, this is using the belief that we are very good at identifying features on the human face, right? If you show me two different pictures of people, even though they look the same, they have the same ethnicity, I will be able to tell you that they're two different people, right? Even if they look the same, right? So similar with data, right? Even if those two data belong to clusters that are very close in Euclidean space, right? You'll be able to tell those apart just by slight tweaks and features, right? So let's map those dimensions, those features, to different facial features, right? For example, we have height of eyes, width of the mouth, height of the face, and you can see all the other variables, right? And you can map any dimension onto these variables, and then all you need to do is to see what looks different is just look on the graph and say, all right, to find something similar, we say, all right, who look like brothers, right, or sisters, or cousins? And to say, who's the outlier here? Look at this clown, District of Columbia, come on. Okay. The basics. How do you start with a data analysis, right? Well, look at the columns, use some 500 summaries, box and whiskers plot, density plots, histograms, overlay predicted models on your scatter plot. I mean, all these tools you've seen over and over in your classes, right? And that's how you start, really. I mean, it's just sort of like trial and error in the beginning. You get the data set, and you just start making plots. You start plot, all day, plot all day. That's all you do for like hours. And then you find something random, like an anomaly, and then you investigate that anomaly. And you think, all right, what am I trying to do? Maybe there's some underrepresented population that is consuming this product, right? So that's the kicker. And then once you find that, you're like, oh shoot, this graph like showed me this. And then now let's investigate that, right? It's like graph, idea, investigate. Bad idea, go back. Plot, idea, investigate, right? This process, just plotting, simple summaries, right? That's the key. I've tried to show you a bunch of examples of data visualization, but really, where you do the data visualization is just it's the creativity of it, right? You don't even need to know how to do ggplot going into the competition to make an epic graphic, right? You can learn all that you have like 48 hours. That's enough time to make a graphic. Like, you just have to have the inspiration to create something cool and know what you can do, right? It's not like what you can do. You can do pretty much anything, right? And like, say you want something super novel that you know is going to be insane to implement. Maybe just go online and paint or something, and then create it yourself with some shapes, right? Like, and then just maybe you can use some Photoshop and even Microsoft Paint or whatever, and then just PDF that and then put it in your presentation, right? Or add that into a graph somehow, right? Overlay it, just do something clever. But I mean, most you can do with ggplot. Anomaly detection. So what is anomaly detection? I've talked about this a little bit, and I think that this is a good starting point for when you're looking for ideas for how to go about presenting to the crowd. Trying discovering patterns in the data, right? The goal is to hopefully find a pattern or find something that's just really off, right? So last year, it was Edmunds Data. They were a website that had basically metadata on car sales, like at dealerships. So they would tell you, their goal was to tell you the fair price of a car, okay? So one thing I noticed when I was messing around with ggmap and I was plotting, I subsetted the data, I pulled out hybrid cars. And I was like, all right, that's maybe a good place to start. Hybrid cars. Let's look at hybrid car sales. And let's look at Los Angeles region. And then I found, I was like, oh, so they have the world map I had earlier and how there was like a red density, right, showing that you had a higher infant mortality rate. So it was like that map, but it was on the price of the car being sold and how many cars. And it was in the LA region. And I noticed there were a few places in the valley that were just really dark red, and everything in this lower LA area was really light color. And I was looking on Rodeo Drive and stuff, and no red. It was all just light color. I was like, what? I would expect there to be Beamer i3s or whatever, crazy expensive hybrids on Rodeo Drive, Sunset Boulevard. And yet in the valley, I have the most expensive places, right? So I was like, well, what's going on there? Well. So I looked into it a little further, and it's this one dealership up there that just cranks out very expensive hybrid cars, like a BMW dealership or something. I was like, okay, well you could go off that, or you could go off a lot of things, right? There was a plot that sort of led me onto that. it wasn't what we ended up doing. We did analyze hybrid car sales, right? But we didn't use like that point. Okay, so anomaly detection. Anomaly detection is like playing Where's Waldo. If you guys played that game, Where's Waldo, right? You have a book. It's got a bunch of images, things like a collage, and then Waldo is somewhere on this collage, and you know what Waldo looks like. Well, anomaly detection is like playing Where's Waldo, but you don't know what Waldo looks like. You don't know what he's wearing. You're playing on the scale of Manhattan, and sometimes you see Waldo, but it's not really Waldo, right? And this is the case where you see a pattern that is just like there from randomness, right? It's just like an artifact. Okay. So that's anomaly detection. So let's try and use anomaly detection to help in a couple situations. How many of you guys remember the game Halo? Xbox game was the first game that was like, first game that came out with it. It was like with the Xbox, you got the game of Halo. Epic game is first-person shooter, meaning that you have a little crosshair on the screen. You're just trying to, shoot the opponents. So let's look at it from an anomaly detection standpoint, and then let's look at credit card fraud. So what are the possible ways you can cheat in the game of Halo? And so here you can see the crosshair here. So this is sort of like what the screen looks like, right? You're just shooting that area. So how would you cheat in Halo? Okay, what if you built a program that just would automatically find the heads of all of your little opponents and then would just start shooting in that direction, right? How hard would it be to write that algorithm? Not, right? You write a helper function, identify face, right? Maybe the other one, get location, and then point at location, and then fire, right? That's the whole function, right? It will work every time, and all you need to worry about now is just identify face, okay? Well, object tracking is insane right now. We have all the quickest object trackers, even multi-object trackers. Okay, so an automatic headshot program. If you were playing with people online and they were like automatically headshotting everyone, they were just destroying people. Like, wow, they're told like modding the game, right? Well, you can pretty easily write one of those functions. Or like if they're just flying around the map. I remember like in that first Halo, there were a lot of like glitches, what people call them. And so like one would be like people would get a sniper rifle and they would just like somehow manage to fly up onto like the top of the map and then would just like sit there the whole game. And it was like totally illegal. Like it was just not. They didn't design the game to be like that, but you could do it. So okay. So there are people cheating in this game. How, if you're